All right, everyone, let's get started. Holy smokes, my camera is super bright. Let's have this adjust. Um, Good morning, everyone. Welcome to Autodesk Virtual Academy, brought to you by your friends here at Kativ Technologies. I'm Nigel Mbayak, and today I'm joined by my good friend Cameron Wetton. Cameron, you there?
I am here.
Awesome. Great to hear you and now see you. So Cameron, welcome. I know you've done a couple of AVAs in the past, so definitely welcome back to the whole process here. And I'm really excited for the session we have going today. So as you can see there on the screen, what we're going to be going over is some automated assembly generation with iLogic. It helps that Cameron's part of this session because Cameron works directly on our automation team here at Kativ. I'm sure he'll talk a little bit about that, but essentially a lot of our customer projects that they have us automate, things like this or in this nature, or even way more complex than this, Cameron usually ends up working on some of those projects for those customers. So definitely glad to have you as a resource today. I know you're going to go a little bit into more detail as to what all of this means and how to start utilizing some of the power that Inventor has within it. I know last week we did some VBA or some Visual Studio. We looked at some of the automation on that side. Today we're going to be looking at it from the iLogic side within Inventor itself. So there are a couple of ways to do it. Like we always mention, if you do have any questions at any time, go ahead and chat those in, and our team will go ahead and answer those in the background. And if you have any further discussion that you want to have about automation for your company entirely, let us know, and we can help you point into the right direction, because there's 9 ways to skin a cat, and Inventor, there's a lot of cats, I guess. So with that, I'll go ahead and pass it over to Cameron, and go ahead and take it away.
All right, thanks, Nigel. Yeah, so like Nigel said, there's a lot of ways to automate Inventor, and there are a lot of ways to automate assembly creation in Inventor. One of the ways that people commonly do that is with iLogic, but there are other ways like through the Visual Studio interface, creating add-ins, like we've done with some of our AVAs in the past. And like Nigel said, I'm on the automation team, so I do a lot of this stuff day in and day out. And today I want to talk about kind of a unique one, a unique approach to assembly generation that you don't see a lot, but I think there's a lot of power in it. And especially in most recent versions of Inventor, it's got a lot better. So let's jump into that. Um, so like I said, a common use of iLogic. Let me go ahead and stop my video here for a minute. We'll just go into the presentation. All right, so like I said, a common use of iLogic is to configure assemblies, and this is usually done by turning on and off the components that are in the assembly or by component replacement. But today we're going to talk about, we're going to look at a different way, using iLogic to generate new assemblies by placing and constraining components on the fly. This is useful for creating assemblies from part or assembly templates, and the end result is an assembly with only what you need in it. There are no extra unneeded components that are turned off but are still in the assembly. So we are going to focus on the major iLogic functions that are useful for this approach, namely adding components and content center parts, creating the most common types of assembly constraints, and creating component patterns. And like I said, recent versions of Inventor have introduced new iLogic functions that make these tasks much simpler than they used to be. The old way didn't have many iLogic shortcut functions available, so you really needed to have a certain level of knowledge of Inventor's API to really get anywhere. But these new iLogic functions simplify the code a lot. So take a look at these two blocks of code here. It's a little small on the screen, but we're not really going to get into the details of what we're showing here. But I just kind of want to put this up as an illustration of the top block of code is the old way of placing a component in an assembly, and the bottom block of code is the new way of doing it. So just at a quick glance, you can see it's much simpler code to write. Quite a few less lines of code involved in one than the other. Now, you don't necessarily need all the lines of code here to just place a component. Some of this is, like naming the occurrence once it's placed, making sure that it's visible. That usually comes in true automatically. And then setting the part color is not strictly necessary for just placing the component, but I put it in here as an example of all of this code that you see on this block is basically what this one line of code down here is doing. It's setting the color, it's setting the visibility, setting whether it's grounded and all that stuff. It's doing all that in one line of code, where the old way of doing it was about this many lines of code up here in the top block. But the most important part of this, not so much the number of lines of code, but the more important part of this is that the original code here, the old way of doing it, is there weren't really any iLogic shortcut functions involved in doing this. You had to get down into the Inventor API and understand those methods and properties of the Inventor object model in order to be able to write this. But now with the new iLogic functions, it's really simple. You just pull this out of the snippets, put in, change the parts that you need to make it specific to what you're trying to do. And then it's so much easier to do. So so this is for placing just a component in your assembly. Placing a content center part was at least this amount of code plus more for accessing the content center itself. That is also much simpler in just a single line of code. And I'll show you an example of that today. And a similar idea for creating assembly constraints now can be accomplished with a single line. So yeah, let's just jump right into it. So I'm gonna close out all this stuff here. Let's go over to Inventor. And I've got an example assembly that we're working with today. It's just a little air engine that I designed and built in one of my university manufacturing classes. And we're not going to build the whole thing, that'll just take too long, but we're going to focus on placing a few of these components, writing the iLogic to have Inventor place the components for us and to constrain them in place. And so we're going to be placing this chassis, the axle, there's some bushings, the bushing on the flywheel and the bushing there. And then there's some bushings at each part where the axle goes through the chassis. And then we're also going to see an example of placing components from the content center, we're going to place these bolts. And I'll show you an example of how to create a pattern, a component pattern with iLogic code. So we'll use this assembly as our example. We'll kind of come back and forth, refer to it. But I'm going to go ahead and open up. I've got an empty assembly that I've started here. Right now, there's nothing in it. There's no code. But we're going to go ahead and start writing our rule. So we'll go to our iLogic tab, right-click, add rule. We'll call this build. And all right. So the first thing I want to do is we are going to be placing parts from a specific folder on my hard drive that contains all of these engine components here. So I'm going to just make a common reference to this folder. So I'm going to go ahead and copy that folder location, and I'm going to make a variable here to hold that information. So just paste that in. So there's our parts folder. We're going to be using that quite a bit. So I'm just going to create a common variable for it. All right, so the first thing we're going to do is we're going to place the chassis. And we're going to go over here to our snippets, and we're going to find iLogic assemblies / components. So this is a new category. It wasn't always there. It was introduced 2019, I think, was the version that was introduced.
Yeah, I think you're correct, Cameron, if I remember correctly. I think I wrote the blog for that, so I think it was 2019.
Okay, perfect. Thanks, Nigel.
Yep.
All right, so we're just looking for our basic add component. So I'm going to go ahead and double click that. And first thing I'm going to do is just rename this here so it's not quite as generic. Call that chassis comp. And then, okay, so let's take a quick look at what's going on here. Some of these you can kind of tell what they're getting after. This is obviously a file name. This is going to be the component name in the browser once it gets placed. And then, but if you're not sure what any of this stuff means, it's always a good idea to hover over that function right there, and you'll see it pops up and at least gives you an idea of what that. So the first one is going to be OCC name as string. Okay, so that's, like I said, that's going to be our current name once it's placed. The file is the next argument. Then after that is going to be our position. If we want to place that have it be placed in a specific spot, we can give it a matrix or a point so it knows where to place it. You can also set whether it's grounded, whether it's visible, and you can give it an appearance asset name if we want to set it to a certain color or something. Okay. If you ever need more info, or if sometimes these are not quite as clear exactly what they're talking about, and so it's actually good to go, and I'm just going to hit this help button right here, and that's going to pull up my browser and go to the Inventor help, and it automatically goes to this iLogic help section, which has got if we go to the functions for rules in iLogic, there's some good documentation on the functions for iLogic. Unfortunately, it doesn't look like they've updated this section to include the new stuff, so there's no iLogic components section here, but I did find that it is down here. If you scroll a little further down and go to iLogic API, expand that, and then we're going to be looking under iLogic interfaces. I'll expand that as well. And if we go down to the iManaged group of interfaces, then we will be able to find the things we're looking for. So specifically the ones that we're going to go over today: placing components, placing constraints, and creating patterns. You're going to find those under the iManaged assembly interface, the iManaged components interface, constraints interface, and then down here will be iManaged patterns right there. So the functions will be in there. So if we look under iManaged components interface, you can just click on that. Then if we look down here at the methods, we'll see there, that's content center part. Here's just the add routine right here. So if we click on that, it'll give us some more information. So here's basically the information we saw in the pop-up inside of the iLogic editor. And then down here, it gives us a little more description of what that stuff is going to be. Okay, so this is a great resource for trying to understand what these functions do and what they expect, the values they expect you to give them in order for them to work properly. So, all right, so the first thing we're doing here, like I said, that's the name of the component once it gets placed, and we can name that whatever we want. I'm going to call it chassis. I like to use this is my own personal convention. I put an underscore in front of the component names to let me know these are components that I've manually set the name for, rather than just so I can distinguish them from the ones that Inventor has automatically named. All right, now here's our file name. So we want to refer to our parts folder. So I'm going to go ahead and paste that in there, and then concatenate on the file name, which I'll go and grab from the folder here as well. So there's our engine chassis. Just hover over that, copy it, go back to our rule, paste it there, and I do want to make sure I put that slash in front because it's just basically tacking it onto the front of this, or the end of this parts folder here. So I'm going to need that extra slash to get the full file name. All right, so the position. Now, the first component that it places in, if you give it a position nothing, it's going to drop it in essentially at 0, 0, 0, the origin, which is exactly what I want for the chassis. And I'm just going to, because the chassis is the first component, I'm just going to ground that. So let's go ahead and set grounded to true. Visible true is fine. I'm not concerned about the appearance right now. So let's do that. I'm going to bring that down, make that a little more readable. Okay, so the position, nothing is fine. For the additional components that we're going to place later, we're also just not going to worry about the position because we're going to be creating constraints in order to make sure those end up in the right spot. So I don't really care where Inventor drops the component to start with, because our constraints will handle placing the components where we want them. All right, let's just go ahead and preview that, make sure it's working. So let's save, close. We'll go ahead and save our assembly, and then I'll run the build rule. There we go. It's dropped in our engine chassis. It's given us the name that we chosen, underscore chassis. And in this case, we haven't built any constraints on there. We've just grounded it in place at the origin. So if we highlight our origin here, we'll see ground plane is here, or the XZ plane. And then there's a plane that goes through the axle, and then one that runs right down the middle here. So, okay, so that's exactly what we want. That's good. Let's go ahead and continue building our rule. We are going to, next thing we're going to do is place the axle. And I'm just going to copy and paste this here. And I'll just rename this to axle comp. And change our browser name. And then we need to get our new folder, or our new file name. Grab that, copy that. Paste that there, engine axle. Okay, the position, nothing is fine. Like I said, we're going to constrain that. This one I don't want to ground though, because we are going to constrain it. So let's change that to false. And then that's good. We don't need anything else there. All right, so that's not what I wanted to do. Okay, so we've got it placing. Let's go ahead and do the constraining while we're at it. So now we're going to create a constraint. So we're going to go down here to relationships add. So this is the new group of functions, again, that was added in 2019. These are the original ones we had to work with, where basically the constraint had to already exist, and then we could control whether it was active or not. But now we can actually just create them on the fly. All right, so we are going to, with the axle, let me save this and open up the axle part so you can see what we're working with. I mean, it's a very, very simple part, it's just a simple cylinder. But what I'm looking at here is where the origin is at. So we've got one, the YZ plane is right down the middle, and then these two planes here are right down the axis of the cylinder. So basically what I want to do is just drop this part in to our assembly, and two of the origin planes are just going to match right up, and the third one is just going to be offset from the ground by whatever the distance is here, 1 inch. Okay. So the simplest way for me to do that is to use, go back to our assembly here, go into our iLogic rule. The simplest thing for me to do here is to use this snippet called add UCS to UCS. So UCS is a user coordinate system. So if you've got user coordinate system set up in your parts, then you can just tell Inventor, okay, this is my named user coordinate system in one place and named user coordinate system in the other place, match them together, and it basically creates 3 flush constraints between those coordinate or planes. But it's also, we don't have UCSs here in these parts, but it's also useful to just constrain origins together. So let's take a quick look at what we've got here. If we hover over that, we'll see that the first item is a constraint name as string. So that's the name of the constraint that's going to get created. We can choose whatever we want for that. And then the next item is going to be the component, the first component that we're trying to constrain, and it's going to be that its browser name. And then the item after that is either the name of the UCS we're trying to connect, or in our case, we're going to change that to origin. And then the second component, and then its UCS, or we'll change that to origin, and then the offsets between each directions. So let's go ahead and name this, and we'll just call this axle to chassis. And then the first component we're going to constrain to is going to be our chassis. So I'm grabbing that component name up there, the browser name, pasting it there. The second component we're going to do is the axle. So I'm going to paste that there. And then here, since we're not using UCSs, we just want to use the origin. What we do is we just replace this with origin. And then we do the same thing here. And the way I know that is from the help documentation. If you go to constraints interface, add UCS to UCS, and you come down here, the name of the UCS in the first component, use origin to refer to the origin instead of UCS. Okay, so that's how I knew how to do that. And then these are going to be our offsets for our X and Z offsets. Those are just fine at 0. The only one we needed to change was this Y offset needed to be 1. Okay, so let's go ahead and save that. Now, if I run this again, it's going to try and place another one in here, which, I mean, normally would be fine, but it's going to try and place another one with the same name, which Inventor won't allow. So just to kind of keep this running, before each time I run it, I'm just going to clear this out. So we've got a clean slate to work with. Then let's go ahead and run our rule. Okay, so there's our chassis and our axle. And you'll see that one line of iLogic code, the UCS to UCS constraint creation, actually created 3 flush constraints between the origin planes. And this one had an offset of 1. Okay. All right, so I'll go ahead and delete those so it's fresh for our next run. Let's go back into our rule. And the next component we're going to do is the left bushing. So that's going to be the bushing at the, you see it kind of in there, where the axle goes through the chassis, there's a bushing there. Go ahead and open that up so you can see it's just a simple hollow cylinder. We're going to place that. So now with that one, what I would do if I was just manually building this assembly is I would use an insert constraint on this edge of the chassis. Open that up, this edge right there, and this edge of the bushing. So I'm just going to do that same thing. I'm just going to tell my iLogic code to do that. Now the trick is, how does iLogic know how to find these edges? And in order to help iLogic find those, we're going to take advantage of, again, some new functionality they've added in recent versions of Inventor by assigning a name to this edge. So I'm going to right click on that, assign name, and I'm going to call this left bushing edge. Okay, so now if we just call that out by name in iLogic, Inventor knows exactly where to find that. I'm going to go ahead and do the same thing for the other side here. Right bushing edge. Okay, so now we've got those two. I like to turn the labels off just to clean things up. That's totally up to you. All right, let's go ahead and save that. And then we need to do the same thing on the actual bushing itself. So I want that edge there, assign name, and just call this bushing edge. That works. Hide the label, save it. Okay, now let's go back to our iLogic rule. And we are going to place left bushing. And we're going to use the same bit of code here. So I'll just copy and paste. We'll call this left bushing comp and give it a name, the actual browser name, left bushing. And then we need our file name. So let's grab that. This is going to be our chassis bushing as opposed to the flywheel bushing, which we'll place later. So copy and paste engine chassis bushing.ipt. Position, nothing's fine, not grounded. Everything else there is good. All right, now let's constrain this guy. And like I said, we're going to do just like we would if I was building this manually by placing an insert constraint. So we go down to our relationships and we want add insert. It's an insert type constraint. Okay, and this is going to be our constraint name once it's placed. And we can call this left bush insert. And then this is the first name of the component we're trying to constrain to, which will be our chassis. So I'm going to grab that component name, place it there. You could create variables for these, just so if you ever needed to change those, there would be one place to do that. If I was, if I was doing this for real, I would definitely do that and make it easier on myself if I ever had to change. But just for our purposes here today, I'm not going to worry about it. Okay, so this second item here is going to be the entity that we're trying to constrain to. So basically what you would pick if you were creating this constraint manually. And there's basically, we're just going to put in the name of that we assign to that edge. So we called it left bushing edge. And it knows it's going to look in that part for that named entity. And then part we're trying to constrain is the left bushing. So we place that component name there. And we called this bushing edge inside that component. And then we have the option of choosing whether the axes are opposed or aligned. We do want these to be aligned. So opposed is equal to false. So that's good. We don't need any offset, so that's fine there. We could lock the rotation or not. Let's go ahead and do this. In real life, that's a press fit, so it would be locked in rotation. And then these bias points are a little more advanced. These are going to be like sometimes if you are creating constraints, the entities that you pick and choosing the alignment doesn't necessarily remove all degrees of freedom. The constraint could have multiple solutions. It could solve either one way or maybe flipped around the other way or something like that. And so the way that, if you're creating constraints manually, you could just maybe like grab the part, rotate it, and hit the update button, have Inventor resolve that constraint, and it will solve to the solution you want. We don't really have that option with iLogic, so they've given us these bias points that we can use. Basically, some points that you can give, 1 point on the one component and then another point on the other component. And Inventor tries to get those two tries to solve the constraint in such a way that those 2 points come together as close as it can. So that's what those are for. It's for helping with those situations where the constraint might solve in a way that you don't want it to, and you need it to solve the other way. So, but in this case, what we're doing today is just fairly simple constraints that solve the way we need them to. So we can leave those bias points at nothing. All right, let's go ahead and save and test that. There we go. So there is our left bushing placed nicely. Let's go ahead and take a look at the constraint that it made. There we go, left insert. And so if we look at that, we'll see the rotation has been locked. So that Boolean lets us choose that, basically essentially that check mark state. So, all right, so far so good. Let's delete that. We'll go ahead and save our assembly. Go back in. Now we're gonna do the same thing for the right bushing. It's gonna be very similar. So I'm just gonna copy this bit of code and paste it again and just go here and change some stuff. So we'll call this right bushing comp. Component name will just be right bushing. It's the same file. All that looks good. Constraints. Just rename those. And then we're going to go inside the chassis part. We also created that, we named that other edge, right bushing edge. And this is going to be right bushing edge. There we go. So that should be good for getting both of those. There we go. There's our right bushing. Okay. All right. Next thing we're going to do here is we're going to place the flywheel. And the placement of these components is all pretty straightforward. But on each one of them, I'm trying to show you different ways of constraining using some of these different constraint options here. And then once we get down to the center component, you'll see the placement's different there. So this is going to be our flywheel component. Let's go grab the file name, engine flywheel. Okay, so that placement looks good. Now we'll constrain the flywheel. So the flywheel I want to be able to spin. So I don't want to remove all degrees of freedom. I could just have it, the origin of the flywheel is basically in the same spot as the axle origin. So I could just use a UCS to UCS constraint and just match up those origins, and it'll create 3 flush constraints between them. But in this case, I want the flywheel to be able to spin. So I don't want to create those constraints. And so instead, what I want to do is I'm going to create, I didn't rename this. So let's do flywheel comp. There we go. So instead, let's open up the flywheel. Take a look at its origin. So I've got the YZ plane is going right down the middle here, and then the other 2 go through the axis. So what I want to do is I'm going to take this YZ plane and I'm going to match it up with the YZ plane on the axle. So that'll remove quite a few degrees of freedom. And then the last constraint I'll use a flush constraint for that. And then the last constraint I want to make is a mate constraint between the x-axis of the flywheel and the x-axis of the axle. And then that'll remove all degrees of freedom except for the 1 rotational degree of freedom. So let's go ahead and do that. So the first one we want to do is a flush between the 2 planes. So I'm going to come down here and go add flush. And we can call this flywheel to axle YZ. And let's see, the component we're constraining to is our axle. So we'll grab that component name, paste it there. And here, like you can see, you can give it the name of like a work feature, like a plane or an axis or something. Or you could do the origin. So in this case, we want the YZ plane. So I'll just replace that. And then this is going to be, the next component is our flywheel. So I'll grab that name, paste it. And then we're going to do the YZ plane on the flywheel. And then offset is 0, and then we don't need our bias points. Okay, so that'll create the one constraint. The last constraint we need for that is the constraint between the two axes. We can't use a flush for that. We have to use a mate. So let's go ahead and grab an add mate. And we'll call this flywheel to axle X. And this will be axle again. And instead of a plane, we're going to just do X axis. So these are the names of the work features. If you're not sure exactly what those are, you can just, every part has the same origin. So you can just come up here and take a quick look at that and you'll see what the names of those are. So they've got to match those names. So we've got X axis. You can even just select on one and come over here and get the name straight from it. So let's do that here for our flywheel. And then we'll highlight that and then double click our X axis and it'll write it in there for us. Okay, so the mate's got a few extra options. We don't need an offset for this. There's these inference types. We don't really need to worry about those. It's going to infer exactly what we want. Basically, the options that you see here are going to be the options that you have when you're manually creating a constraint. All the different things you have to pick and choose from are translated into these different options you can put into the iLogic snippet. So again, if you're not sure exactly what those are, you can look at the documentation, or you could even just go open up the actual manually place a constraint and see what options there are, and you can probably figure out what they're asking for. So, okay, that's good. Let's try that. Let's go ahead and save our assembly. Run rule. There we go. So there's our flywheel, and it's got a flush constraint between those two planes and the mate of the axes. And then it's got that rotational degree freedom that I wanted. Okay, perfect. All right, let's go ahead and delete that and clear it out for the next run. Okay, so the last component I want to do here is do the, well, I was going to put the bushing on the flywheel, but that's going to be the same thing. We would just use an insert constraint, add some named entities. I think we've already seen an example of that, so I'm going to skip that. And let's just go straight to the bolts. So on the example assembly over here, we'll see that they've got these bolts here. And I've already taken a look at what those are inside the content center, and that's going to be a cross-recessed panhead machine screw. So if we go up here, place from content center. So this is important. You got to figure out which category you need to grab a family from. So that's going to be under round. So fasteners, bolts, round head. So we want to make note of that because we're going to have to put that in the iLogic snippet to tell it where to look. And then we also want to make note of the family that we're looking for. So I've got cross recessed pan head machine screw type 1 inch. So that's the family we're looking for right there. And if we were to place one, then so this is going to be a 1/4 by 1.5 UNC. Okay, so that's what we're looking for. So I'm going to go ahead and I'll take a snip of that because I'm going to want to reference that here in a minute, especially the family name there. There's no way I'm going to remember all that, so I've got a screenshot of it here. All right, let's close that. Yeah, let's just go ahead and place it just in case we need it to refer to it again quickly. Okay, let's come back over to here, go into our rule. All right, so we are going to place chassis bolt. All right, so we're not going to use the same add component that we were using before because we need to access content center. So we're looking for this right here, add content center part. So let me drop that in. Now this snippet is a little unusual because it actually drops in 2. It's like if we ran this, it would add 2 content center parts. But the reason they did that is because there's actually two different methods of adding a content center part, and they wanted to have the snippet show an example of each of those. So that's why there's two in here. We'll only need one, but we want to figure out which method we want to use. So this method here, you'll see the first thing that you input here is going to be the name of the component, just like we did up here. This will be the browser name once it gets placed. And then this right here is going to be the category structure that we need to navigate through. So fasteners, bolts, this is getting us most of the way there. We just need to change this to round head because that's the final category that it's in. And then this is going to be the name of the family. And then this right here is going to be the string that uniquely identifies one of the rows inside of that family table. Specifically, it's going to look for this string inside of the column that's named designation. And Content Center basically enforces each family has to have a designation column. So that's good. You can, and they all have to have unique values. So that is a good way to uniquely identify a row from any family. So that would be a good way to do things. But the trick is if you ever have, like if you have an iLogic rule that says, okay, for one product type, let's say I have an assembly I'm trying to configure where I can switch between product types and it configures different things. And for one product type, it's got, it needs to place something from one content center family. And for another product type, it's got to place something from a different content center family. Then that's fine. I could use the designation, but there's no guarantee that the format of the designation string is going to be the same between both of them, because that's completely up to how whoever created the family and how they decided to organize that designation column. So you might have to write some special casing that says, okay, for this product type and this family, this is what the designation string is supposed to look like. And for this other family, it's got to be different. So it's certainly doable, but it just can get a little bit tricky. And so they've given us this other method of doing it. Instead of calling out the designation, you'll see most of this is the same. That's the component name. There's our category structure. There's the family name. And then instead of just a single string for the designation, we have this array of key value pairs. And this right here, it basically means it's a way for us to specify, okay, I want you to look in this column, name designation for this value, and then look in this column, thread length for this value. And then we can continue to add more depending on how many columns it takes to uniquely identify a content center part. So the logical thing to do would be to use the key columns, like the ones you use to actually pick apart when you're placing one manually. But it doesn't have to be key columns. So, and the difference why you might want to use this one over this one is, like I was saying, sometimes the designation formatting is not always, well, it's definitely not guaranteed to be consistent. So instead, you could just go by which columns you want to look up. So we're going to use this second method. I'll show you how that works. So we don't need this first one. I'll go ahead and delete that. And we're going to use this. So this is the name of the component that's, when it gets placed, the browser name. So we'll just call this chassis bolt 1. And okay, so like I said, this is mostly gets us there. We are in fasteners, we're in bolts. We just need to change this to round head. So that was the category that it was in. And then this is the name of the family, which is going to be cross recessed pan head machine screw space dash space. You got to make sure you get it exactly like it's written out. Type 1, but it's not a 1, it's actually an I. So I got to make sure I put that. And space dash space inch. Okay, so there's that. Let's bring that down to make it more readable. Okay, now we need to specify which columns we want to use. So let me pull my screen snippet over here. These are the key columns that you use to uniquely pick a row when you're manually placing. So it makes sense to go ahead and use these. And you have what you can put, the value that you can put in here. It can be either the actual, the display name of the column, or each column also has an internal name. So the display name is, it can be anything, and even more than one column can have the same display name, but which could definitely be a problem trying to specify it in iLogic. But each column also has a unique internal name, so they're guaranteed to be unique. So that's probably makes the most sense to try and use that. In fact, I think there in this family there are actually 2 columns that are named thread description. So if we try to just use that, it's not going to know which one we're talking about, and it'll fail. So we definitely want to use the internal names of these columns. So what's displayed here is the display name. So we don't want to use these, but we need to go look up what the internal names of those columns are going to be. So I'll save this, close it. Let's go back. Well, I guess we can just go to place from Content Center right here. There's our family. If we open this up and we go to the table view, so each of those key columns are going to show up in red, and you'll see as I hover over it, it tells us what the internal name of that column is. So instead of nominal length, we'll want to use NLG. Let's go down here. Thread type is going to be TS. Thread description is size underscore SEL. Okay. Yeah, all right, so let's do that. So now we know what columns we're looking for. Let's go back into our rule. And let's see the first one. Let's do as size underscore SEL. That's going to be our thread size. And that will be, I wanted 1/4. So basically put it in exactly what it looks like in that column. So instead of 0.25, it is 1/4. So I want to make sure I put it in so it finds what it's looking for. And let's see, the next one is NLG, which is our nominal length, which was 1.5. And then I need to add another one for a third column. So we'll just add a comma after that, and then add our column internal name, which was TS for the thread. And then the value that we want it to look up is going to be UNC. Okay. And then this stuff is the same as it was for the other add components, position, grounded, etc. We don't need to worry about those. All right, so let's go ahead and make sure that works. Make sure we haven't made any typos or anything in there. Let's just run it and see what happens. There we go. No errors. I see a bolt there. That's the one we want. It's not constrained yet. We'll take care of that. Okay, let's go back in and add some constraints. All right, so this one, let's go back out here. Take a look at our example assembly. So this one I want to basically constrain to this hole back here, and then we'll constrain one, and then we'll create a rectangular pattern to place the other 3. But this one, so I can go into the engine chassis part, and then name this edge, assign a name to it, and that works just fine. And we can do an insert constraint. But I can't do that with the content center part, right? Because this is a standard content center part. It's read only. I can't modify it. So I don't have the option to go in and name one of these edges. So instead, we also have the option of using the origin. I can figure out where the origin's at and then create some origin constraints and do it that way. Or I can use what's already in here. Look at the imates that are in there. So there's an insert, half of an insert constraint right there. That's exactly what I want. So in order to match that up with another imate, I'm going to go ahead and go into my chassis and just create the other half of that imate where I want it. So let's go to our manage tab and create imate. And this is going to be an insert type constraint. And we do want these to be opposed. We want it on that edge right there. Let's go ahead and give this a name, insert. I think the one in the content center part was named insert IN1, so we'll just give it the same name. And there we go. Now we've got our imate there. Save that. Go back to our iLogic rule and take a look at the snippet for placing an imate. So constrain chassis bolt. And we're going to go down here. So there's 2 of them. There's add imates and then imate add by IMate and entity. So we could have named the circular edge in the chassis part and then use the half of the IMate that's in the content center part and the entity, named entity in the chassis, and then that would work. We could use a snippet to connect those two that way. But I want to use this one, this add IMates. So just drop that snippet in, and this will be our name, which is just chassis bolt. And let's see, the first component we're constraining is the chassis. And the name of the IMate, this will be the name of the IMate that we're doing. So this is insert space IN1. And then the bolt that we've placed, put its name there. And it's also insert IN1. All right, let's test that out. Save, run. There we go. There's our bolt. And there's our IMate connected up. All right, so last step is to create the pattern. And this is really simple. Go down here and pattern the chassis bolt. All right, and we are going to go right here. We can do circular pattern, rectangular pattern, feature-based patterns. We obviously want rectangular pattern. We'll just call this chassis bolt. And then this will be the name that gets created of the pattern in the browser. So I'll just call that bolts. And then this is the name of the component we're patterning. So that'll be our chassis bolt. This is the quantity in the first direction. So we want 2. And then this is the direction, or sorry, the spacing, which is 2.5. And then this is the we could give it an object. Basically, whenever you create a pattern, you have to pick an entity to give it a direction, like for the column and the row. And you could either you can pick something that's inside of like a subcomponent, like an origin of a subcomponent or an edge of a subcomponent. If you're doing that, you have to tell Inventor, this is the component I want you to look into. And so if you are doing that, then you give it the actual, you could give it a component occurrence object here. But in this case, I'm just going to go with the assembly origin. So I don't need to give it a component. So that's why nothing is fine. I'm just going to leave that at nothing. And then let's see, what axis are we working? Yeah, we want, I think that is x-axis. Yep, that's x-axis. So that's good. We'll leave that. And then natural direction true is good. Now this is for the second direction. Quantity of 2 is good. The spacing for the second direction is 5. And the entity name for this is going to be our z-axis. And the natural direction true is good on that one as well. And that's it. So let's go ahead and do that. If you get it and it's patterning in the wrong direction, so you just go in and flip that natural direction from true to false, and then it'll flip it to go pattern the other direction for whichever row or column. So, but in this case, that's exactly what we want. All right. I think we're getting close to the end here, so we should probably stop there and maybe open it up for some Q&A.
Yeah, let's go ahead and take a look. I know there's a number of questions that we need to get to, so let's jump over there to Q&A. So if you haven't already typed your question in, go ahead and do so, and we'll go ahead and start addressing them. Let's start from the top. All right. So what versions of Inventor have the simplified iLogic functionality? I'm pretty sure it's 2019.
Yeah, I know for sure 2019 does have it. I'm pretty sure 2018 doesn't. So I think that's the version they introduced it.
Yep. Boom. That's 2 questions done. I'll take that because it's the same question twice. What do you need to get files from the vault if they don't exist locally?
That is the thing. These snippets are assuming that the files are available locally. There's no interaction with the vault here at all. If you needed to have some interaction with the vault, that gets into some pretty deep vault API stuff, which is doable, but it is definitely a lot trickier. So yeah, if you're going to be running stuff like this, the stuff definitely has to be local, with the exception of placing content center parts. If those are not local, they have built those content center add component snippets to actually pull them from the content center library itself. And so if those aren't local, they will get created
Yep.
on demand. So
All right, so that takes care of that. What's the advantage of using like named edges or feature naming instead of using attributes?
I mean, they're really kind of the same thing. The right clicking on an entity and giving it assigning a name is actually taking advantage of attributing. It's doing that in the background. It's just a much more user-friendly front end for doing that. So, and you also get the nice little display of the little label pointing to it. So it's using the same functionality in the background. It's just it's a more
Just a
user-friendly
different
interface.
interface to get to the same result, essentially.
Yeah.
Good friend Andy here. We use Content Center that's located on the Vault server. I've noticed that it's slow when running replace or change size rules. Is there a better way to have this replaced quicker, possibly using iParts? If it was up to me, I may or may not just get rid of the concept of iParts myself. I know I feel very strongly about that.
Yeah. Yeah, me too. The only iParts are useful for creating content center families, and that's about it for me. I don't know. It depends.
Yeah, it might be a network thing too, right? So
What was that?
perhaps, yeah, it might be a network thing, right? So like Andy,
Oh
it would be
yeah,
really
absolutely.
interesting. I talk to you on a pretty regular basis, Andy. Let me know what kind of slowness it is, right? Whether that's seconds or hours, or I don't think it's hours or minutes or something. Let me know. All right, Jeff asks a question here. I've got a part that has a custom user form. Can you write iLogic code to bring up that form so the end user can enter custom dimensions before placing? The answer is yes.
Yeah, you can. There are snippets for launching forms. If we go in here to
Forms.
Yep.
Yep, and then you just
Now,
pull the form.
yeah, so I don't know that you can have this rule launch a form from another part specifically, but what you could do is you could have this rule launch another rule that's in a component, run rule in component, and that rule then launches the form. So, because I don't see a show form in other, like to run a
Right,
launch
you'd have to run a
from
rule
another
to,
component, but
right, you'd have to run the rule to the part. You have to
that
run a
then
rule that
launches
runs
the
a
form.
rule in another part which runs the form for that
Yeah.
part.
Mm-hmm.
Okay. Is it possible to use iLogic to add structural shapes from the content center? Is that for like the context of frame generator? That would be interesting to note there, Jeff, because
That's a good
it gets very
question.
tricky.
I know that these snippets up here, this add content center part is only for standard content center parts, not custom content center parts. And all of the structural families inside of content center are custom families. And when I say custom, I don't mean like the user created the family, but it has a custom column, which means when you place it, you have to choose like with the length, essentially the length of the member, right? You have to choose what the length of the member is. And then it instead of saving it into the standard content center files folder, it saves it into like a
to the
user
custom folder.
Yeah. And
Yeah.
so I know for sure that this snippet does not work with those custom families. It only works with standard families. And
Yep,
again,
and it
I'm
would be
not talking
interesting.
about like custom content that the users have created. Like if you've made your own families of components, you can by all means use them as long as you're placing them as standard. If that hopefully that makes sense.
Yeah, hopefully that makes sense. It does to me. So
Yeah.
hopefully it does to everybody else. If you have any questions about that, let me know. But long story short, Jeff, or Jeffrey, I guess, it is for frame generator and tube and pipe, like routed systems specifically, for like structural shapes and iLogic, they oftentimes don't play very well together.
Yeah, the API just really isn't developed for interacting with those tools like frame generator, tube and pipe. So yeah,
Yep.
that's an area that needs some more development for sure.
Can iMates be created on feature geometry programmatically using assigned names with iLogic? It's also
That is
something I'm not a huge fan of. But
good question. I don't think there's a snippet for that, but
I don't think so too. I think you'd probably have to go in the API.
yeah, I think you'd have to go to the API for that.
Are you going to do a session on automating the drawing for this assembly? So drawing automation is a whole nother ball game, because there's so many options when placing the component, specifically the location in which the view gets placed. So when you get to drawing automation, it gets a little bit more complicated, and by a little bit I mean a decent amount more complicated.
Yeah.
Um,
Although I do
so
know in this version, the most recent version, 2021, they did add a lot of new snippets down here for drawing automation. So
Yep.
these are your classic drawing ones for basically scaling and placing views and stuff. But this drawing section, they've actually added a lot of really cool stuff for creating dimensions, balloons, leader notes, all that kind of stuff. So definitely, if you're interested in that, definitely take a look at these. Go through the help documentation, find out exactly how these work. There's a lot of power here. They've added quite
Yep. Yeah, so you're gonna want to definitely do some reading,
And
because
I know that recently one of our other developers here at Kativ, Matt Bussey, I think he did an AVA on some
on
basic
some
drawing
basic stuff
automation
in drawing
stuff.
automation, yeah.
So yeah,
Um,
go look at our YouTube channel and go back through the AVA history, and I think you should be able to find one.
yep.
Um, it was pretty recent. I think it was this year sometime.
And then Tyler asks, can you access the project files reference list with iLogic? Sometimes the components aren't always in the same static folders.
Yes, you can access. Well, there's not a snippet for that. I wish there was, because it's definitely useful. But yeah, there's an API call for getting to the. Let me see if I can remember it off the top of my head. It's like this.
Yep.
Location dot design project. Yeah, there we go. Design project manager dot act design project dot path. I think. Workspace path. There.
Ta-da.
Workspace. Come on. Where's my workspace path? There we go. So that'll get you to your workspace path, and then you can go from there to get to subfolders.
Man, the object model is my best friend.
Oh yeah, absolutely.
Yeah. If you don't already have one, you should print it. I'm just telling everybody on the call. Print it and put it on your wall. It makes things a little easier sometimes. And print it as big as possible. I know that.
Oh yeah, it's tiny.
I remember Eric had this huge object model poster at his desk. That's hilarious, but it worked. What's faster, linking to Excel or having Excel parameters read using iLogic? Same concept.
Probably, you mean like an embedded Excel sheet is probably what they mean
I
by
guess.
Excel parameters. That I think is definitely going to be faster, because those parameters are already there in the model. Inventor doesn't have to launch up Excel to read those. So that's definitely going to be faster.
Yeah, Jeffrey Miller is mentioning he wants to use the standard structural shapes to generate assemblies, not necessarily using frame generator, but using those components.
Yeah, just placing them straight from Content Center.
Yeah, I would be wary about that.
Like I said, that's the snippet here is not going to do it for you, but you could probably get into the API. I think I've tried it in the past, but it's been long enough. I don't remember what the results were.
Try it. Let us know how it goes.
Yeah, because I mean that stuff is there in the API, but
yep.
Accessing the Content Center through the API is a little tricky, and placing parts custom, I'm not sure if the API has the functions necessary to do that, but
right. And then
memory's hazy on that one.
Yeah. Got time for a couple more questions. Can you use iLogic to change the size of a Content Center part? Example, change the length of a bolt. Absolutely.
Yes, but the snippet, there's not a snippet for that. Basically what you could do is you basically just replace it with a new one. You just run this add Content Center part again. One part that I didn't go over that I was going to, but I just ran out of time, was this manage components thing. which, if you place a component and there's already one in there, Inventor's going to freak out because, hey, that one's already there. You can't do that. So this manage components thing, if you add that in, it'll actually know anything that you're using these add part or add content center part or whatever. It knows, okay, if there's one already in there, I'm going to delete it. And it manages that automatically, which is really slick. So you could just have it just run this again, and then you could, instead of just having a static hard-coded size, you could have this driven by a parameter or something. I was going to show an example of this. I just ran out of time, but
We'll do next time.
yeah, it's really slick how it works. You just add this manage component. This snippet is kind of atrocious. It's got a whole bunch of extra stuff there as an example for you, but basically all you need, the important parts of it are these two items right here, begin manage and end manage. You just place this above at the start, put all of your add and create constraints and all this stuff and patterns even in between the begin and end, and it handles all that deletion for you. It's really slick. Give it a try.
Yeah, we'll go over next time. I think that's super useful.
Yeah.
That's all the time we have for questions now. There's a couple more, but they look kind of specific to some certain people's workflows. If you have questions about what you're doing specifically and some of the errors that you're running into yourself, definitely reach out to us. It's hard for us to diagnose what's going on with your code or whatever if we're here on a webinar. So
yeah.
Long story short, reach out to us and we'll see what we can do to help. So I think that's all the time that we have for today. Again, thank you, Cameron, for joining us for today's AVA. I know that we, based on the questions, it looks like there's a lot of interest and it looks like we can come up with a lot more sessions in the future. So definitely be on the lookout for Cameron's name on the calendar again. 90% of the time, I think Cameron's going to be doing something Inventor related. And most of those are going to be automation related since, he is one of the people on that team. That's kind of our bread and butter here at Kativ. So Cam, thanks again for joining us.
My pleasure. Thanks, Nigel.
Absolutely. And thank you everybody for joining us on the web as well. We'll see you again at 10 a.m. Pacific next week. Thanks everybody. Bye-bye.